Okay, today we're going to learn about the product and quotient rules for finding derivatives. Okay, so we'll start with the product rule. The notation they write is that we're taking the derivative with respect to x. So that's how they write that, derivative with respect to x. We're going to be finding the derivative, and product means you're multiplying things. So it's going to be, some kind of function times another function, like f of x times g of x. So to find the derivative of that, they say that you take the first function times the derivative of the second function. So they write it f of x times g prime of x plus the second function times the derivative of the first. And that's the notation how they would write it out. First times the derivative of the second part plus the second function times the derivative of the first. Another way you might see this written in different equations, like I'll write another way to say the same thing. So if I have an equation like y equals something like u times v, like something times something, then you use the product rule. Another way that they would show how you could find the derivative of this, so the derivative of y is y prime, so it's another way to write it. Another way to do the derivative, they would say first, which is the u part, u times the derivative of the second. So first times derivative of second, u times v prime plus v times u prime. It's just another notation for it. Okay, so let's try an actual equation. Let's try y equals 3x minus 2x squared times 5 plus 4x. Okay, so we're going to use the product rule to figure this out. So the first part of the equation is this first set of parentheses. It might even help if you label that, like this part is u and this part is v, if you want to do it like that. So to find the derivative, it's u times v prime times the derivative of this. So y prime equals, so first times the derivative of the second part. The derivative of this second part is just 4. So this times 4 plus the second part, which is 5 plus 4x, times the derivative of the first part, the u prime. So the derivative of this is 3 minus 4x. Just using that power rule. Derivative of 3x is 3. Derivative of this is 4x minus 4x. Now this is kind of messy, so you'll have to clean it up. Okay, so we have to clean this up. So we have to distribute the 4 here. And over here you're going to have to multiply all of this out. So now we'll get 12x minus 8x squared plus 15 minus 20x plus 12x minus 16x squared. Then you can combine your like terms. So there's a couple things that say x squared. If you combine those, you get negative 24x squared. Put all your x's together, you'll get 4x, and then there's a 15. Alright, so that's the product rule. First times the derivative of the second plus the second times the derivative of the first. And we'll practice that several times today. Now we'll try the quotient rule and show you that one. Okay, the quotient rule is when you're dividing things. If you have f of x divided by g of x, two functions being divided, and we're finding the derivative of that with respect to x. So they would just write it like this. Alright, so This one is the bottom part times the derivative of the top. You know, like denominator times derivative of the numerator. So g of x times f prime of x minus the top numerator times the derivative of the bottom, the denominator. And then it's all over denominator squared, g of x squared. So this is pretty involved here. Sometimes people, just so you have like a way to remember it, they call this like the high part and the low part. So they say low, it's like a little song. They go low, d high, like d for derivative. Low derivative of the high part minus high d low. Low d high minus high d low over low squared. Low, 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 low squared. So yeah, I've heard like videos of people singing this to try to remember it. You know, it's just, I know it's cheesy, but it might help you remember it. They go like low d high minus high d low over low, low, low squared. Yep, low d high minus high d low over low, low. Okay, so we'll try one of those kind. So it has an equation like 5x minus 2 over x squared plus 1. So low part times the derivative of the high. Low d high. Derivative of this higher part in the problem is 5. Minus high d low. High part, derivative of the low part is 2x over the low part squared. X squared plus 1 squared. So again, it's a little bit of a mess, and you have to try to simplify this. So you'll have to times 5, distribute this 5, distribute this 2x. So I'll get 5x squared plus 5 minus 10x squared minus 4x. And this minus in the middle, you have to distribute that also. So I'll work that out too. So 5x squared minus 10x squared. So I'll get negative 5x squared. These two negatives here will turn to a positive 4x, and then I'll have a 5. So I'm putting in order, descending order, and the whole thing's over the denominator squared. So there's the derivative using your quotient rule. Yeah, it's a little cheesy, but if you can remember the rule, they do like, I know, it's just singing it again. It's like low d high minus high d low over low, low. Then you'll remember it. Okay, another thing that comes up is sometimes finding the derivative more than once. So if I give you a problem that says y equals 2x to the third, then they might ask you to find the derivative of y with respect to x. So it's just find the derivative of this, and that would be 6x squared. The power goes down by 1, the power rule we've learned. Then they might ask you for another derivative, a second derivative. So they put a little 2 by it, second derivative of y with respect to x. So let's just find the derivative again of this function we just had. So that would be, remember you multiplied 2 times 6, so it would be 12x. So sometimes they have you do the derivative more than once. So that'll come up sometimes. Find the first derivative and then second derivative. You could even do it again and find the third derivative. The third derivative would be 12. All right, so then there'll be some questions about find all horizontal tangents. For a function. and we'll give you a function y equals 2x squared over 3x plus 1. Okay, horizontal tangents. You have to kind of remember what that means. So this is some kind of rational function. You're looking for places where it has a horizontal tangent line, and that would be where the slope equals 0. So what does this mean, horizontal tangents? You're looking for places where the slope equals 0. So you're looking for places where this so you're going to have to find the derivative, because the derivative represents a slope. Find the derivative of this and then equal it to 0. So that's what this horizontal tangents means. All right, so here we have a function and it is a fraction, so we'll have to use our quotient rule. Low part, low times the derivative of the high part, low d high. So 3x plus 1 times the derivative of the high part, which would be 4x, minus high d low, the high part times the derivative of the bottom, the low part. The derivative of that is 3 over low low, denominator squared, 3x plus 1 squared. So we'll have to simplify that a little bit. Again, we'll have to distribute things, multiply things out in the numerator. So that gives me 12x squared plus 4x minus 6x squared. If I simplify that a little more, it gives me 6x squared plus 4x over that denominator squared. So that's your derivative. That's your y prime. So we were saying if I'm trying to find places where there's horizontal tangents, I'm trying to find places where the slope equals 0. So when would this equal 0? When would this fraction here equal 0? All right, so we have 6x squared plus 4x divided by 3x plus 1 squared. When will this equal 0? Well, just doing some math, and you want to get rid of fractions. People don't like fractions usually. So to get rid of this fraction, I could times by that denominator, 3x plus 1 squared. I could multiply each side of the equation by that. And that'll cancel out that 3x plus 1 squared. So now I have 6x squared plus 4x. And if you take 0 times anything, you get 0. So it's looking for places when this equals 0. So you can factor this and solve it. Factor and solve. This has something in common. I can factor out a 2x. That gives me 3x plus 2. Set those equal to 0 and solve. And that gives you the answers of x equals 0 and negative 2/3. Divide by 3, divide by 3. Yep, x equals negative 2/3. So that's places where there's horizontal tangents, where the slope equals 0. At 0 and negative 2/3. Okay, one last example. There's some equations you're going to see where they define things like f of x and g of x. So they'll give you some information like g of 4 equals 3 and g prime of 4, the derivative, g prime of 4 is negative 2. And they'll give you another thing like h of 4 function values is negative 1 and h prime of 4 equals 5. So they give you a bunch of information. Now we'll do an equation with it. Now find f prime of 4 if you're given this equation. If you're given f of x equals g of x times h of x. So this is two functions being multiplied together. So to find the derivative of those, you have to use the product rule. And we defined that earlier in the video. It's first times the derivative of the second plus the second times the derivative of the first. And you're trying to find us for a certain value for f prime of 4. So you can plug in 4 for all these x's. We're going to use g of 4 and h prime of 4. And then this one's h of 4 and g prime of 4. And we gave you all that information at the top, so then you just have to plug those things in. Like g of 4 is 3. H prime of 4 is 5. H of 4 is -1. G prime of 4 is -2. So it's just going to be 3 times 5, which is 15, plus negative times negative is positive, so plus 2. So your answer is 17. F prime of 4 equals 17. I just brought that down. So it's kind of interesting. They give you some, definitions of for what values, function values, and then you use it to find derivatives. So here's another one, just one more example of that. So if you have f of x equals g of x plus 2 times h of x, 2h of x. So we'll still use this given information at the top. Use all this given information. And again, kind of the same thing. We're going to have to find f prime, again, of 4. Find f prime of 4. Find the derivative of a certain value. What's the derivative when x is 4? So to find f prime of x, well, it's not times this time, so it's not the product rule. It's more just like our regular derivatives that we've previously learned. So the derivative of g of x is g prime x. And this is a constant times a function. It's just a constant times the derivative of that function. All right, so now again, we're trying to find f prime of 4. So you can now just plug in, we're finding g prime of 4, 2 times h prime of 4. So now we can plug in the values from up above. G prime of 4 from up here was -2. And 2 times h prime of 4. Again, h prime of 4 was given to up above. It was 5. So it's just plugging in values. So it's -2 plus 10. The answer would be 8. Equals 8.